Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about the other trig functions, tangent, secant, cosecant, and cotangent. And then we're going to do some graphing. All right, so when we take a look at the circle and a unit circle, we talk about the values for cosine and sine and tangent. We said that the value for cosine was the adjacent value, or x, over r. The sine trig function for sine is the value of y over r, the side length relationship. And then the value for tangent is going to be y over x. So today we're really not going to learn anything new per se. We're just going to talk about the reciprocals of the relationships, tangent to cotangent, cosine to secant, and sine to cosecant. So what we're doing is we're renaming the relationships reciprocals to cotangent, secant, and cosecant. So for tangent, we talked about the value being y over x. For cotangent, now the value is going to be that reciprocal x over y. Simply, secant is going to be of an angle measure. It's just going to be the side length relationship now of the reciprocal of cosine. So it's going to be the hypotenuse over the adjacent side. And then cosecant is going to be the reciprocal of sine, which is the hypotenuse over the y value, or the opposite side. So the way that I remember it is that there always has to be a co in the pair. So tangent, cotangent, secant, cosine, and sine and cosecant. So there's always has to be a co in the pair, and there's only one co in the pair. All right, so when we take a look at this in a different way, tangent, of course, is sine over cosine, which we said in the unit circle is y over r over x over r. So sine is y over r over cosine x over r. The r is reduced to 1, so you're left with y over x as tangent. For cotangent, it's cosine over sine now, which we can restate as x over r over y over r. Reducing the r's to 1 leaves us with x over y for cotangent. Secant is going to be 1 over cosine theta, which is the same as 1 over x over r. 1 over x over r is just the reciprocal of x over r, which is r over x, or the hypotenuse over the adjacent side. And then cosecant theta is equal to 1 over sine theta, which is 1 over y over r, which is the reciprocal of y over r, which is just the hypotenuse now over the opposite side. Right, so what you can do if you want to stop, you can go through the unit circle, find all the values for tangent, cotangent, secant, and cosecant, and then we're going to draw graphs from 2 pi to pi for each of them. So I'll give you a moment to pause to finish that, and then we're going to take a look at the tables. All right, so this is the table that I want you to fill out from 0 to 2 pi for x, y, and r, and then you're going to find the tangent, cotangent, secant, and cosecant values. Right, for tangent, I'm going to publish the values as shown, so you can reference what you've written down on your table. So you can pause if you want to check your work, and I'm going to move on. Okay, so now we're going to graph the tangent function with the values that we've been given. And we take a look at the values, and I know this is a very busy slide, but we're going to take a look at the values of tangent as we move around the unit circle. And what I do want to notice is that at the pi fours, 3 pi fours, 5 pi fours, 7 pi fours, the value of tangent is going to be, the absolute value is going to be 1. So in the first quadrant it's 1, second quadrant it is -1 because x is negative. In the third quadrant, it's positive because both values are negative. And then in the fourth quadrant, the y value is negative, but the x value is positive, so you're back to negative. So positive, positive first and third, negative, negative second and fourth quadrant for tangent, pi force 3, pi force 5, pi force, and 7 pi force. All right, so this is the way that the tangent graph looks. If you were to graph the tangent graph, from -2 pi to pi. Notice the asymptotes at the pi halves, where the value of x is equal to 0, so tangent y over x. When the denominator is equal to 0, then your value for tangent is undefined. So pi halves, 3 pi halves, negative pi halves, and negative 3 pi halves. And you can see that the tangent values are spaced pi units apart. Okay, so we're going to do that for secant, and okay, so we're going to go through the secant values. Secant is r over x. I know, again, this is a busy table. I'm going to look at my values for secant at pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. I know that cosine is 1 over root 2. So cosine of 45 degrees I'm sorry, the secant is going to be 1 over that value, which is root 2 over 1. Okay, moving on to a graph of the secant function. We realize that the graph is never going to be, because it's the reciprocal of basically a fraction, so cosine is always going to be between 0 and 1, and because secant is the reciprocal of that value, you'll never have a value that's going to be then less than 1. So if you take a look at the function, the graph function of cosine, you see that it varies between 1 and negative 1. And if you take the reciprocal of that value, you'll realize that then the value for secant can never be less than 1. You can see again that we have asymptotes at pi halves and negative pi halves because cosine is 0. The value for x is 0 at pi halves, negative pi halves, 3 pi halves, and negative 3 pi halves. And that's the graph of the secant function. Okay, so now we're going to go on to the cosecant function. Cosecant is 1 over sine of theta. Just like cosine of 45, sine of theta at 45 degrees is root 2. So we're going to take the reciprocal of the value, 1 over root 2. We take the reciprocal of that value at root 2. So the same value that we got for cosine, but we're going to get them as positive or negative in different locations. And then the asymptotes are also going to be different because sine is 0 at 0 pi and pi. So we take a look at the graph function now. The asymptotes again are different. Instead of pi halves and negative pi halves, we have them on the pi increments. Again, the graph never gets to be less than the absolute value of 1, or never between 1 and negative 1. And this is the graph of the cosecant function. All right, so now we're going to graph cotangent. Again, fairly messy graph, but similar to tangent, at the pi fourths values, you're going to end up with a value of 1 for cotangent. And again, now we're going to change our asymptotes. The asymptotes, just like with the cosecant function, the cotangent function, the graphs have the asymptotes where the value for y is equal to 0 now. And so those are going to be on the pi, 0, negative pi, negative 2 pi, and 2 pi. And now because of the change in the signs based on the different quadrants, you'll see that the graph basically flips itself, reflects itself over the prior asymptotes that we had before, although the asymptotes have changed. So there is some symmetry between the cotangent and tangent functions, but it's not exactly the same. Okay, so that's it for Chapter 7.5, Other Trig Function Basics. Please join us in the next edition of Math for inverse trig functions.